on your experiences. And thank you so much. We are honored to have you here. Let's begin.
Sure. Thank you so much. First of all, a mic check. Like everyone can hear me. Harsha, you can hear me well?
Yes, I can hear you completely. I'm just
Okay.
putting myself off the stage once. Any problems
Sure.
there, I'm here.
Sure. Yeah. So as Harsha has already introduced me, myself Sachin Tripathi. I've been working as a data engineer since my whole life. Previously, like currently working at Arnin. Previously, when working with other fintech startups. So my expertise lies around in mostly building cost-efficient data pipelines, MLOps pipeline, and like mentoring people across this industry, mostly in the data engineering domain and MLOps specific to like MLOps domain specifically. That's high. That's like high level about me. Anything like that you would want to know about me, you can anytime reach out to me on LinkedIn. Without wasting much time, because we have a lot to cover in this, so I just start sharing my screen and then start the presentation. Let me know if you are able to see my screen. 1 second. Can you see my screen? If anyone can just give a thumbs up in the chat. Okay, cool. Uh, cool. So we'll just start. So yeah, we have already got the introduction part done. You can just scan this QR code to get these slides available to you. If the fonts are not too friendly to your eyes, you can download it and read it as per your convenience. So I'll just wait for a couple of seconds so that you can scan this and download the slide at your end. Uh, cool. So let's start with this, right? So the way I wanted to start about Apache Iceberg is to start with giving us lot like a little bit about of historical context, like what has driven us to come to the stage of that we need something like Apache Iceberg or Delta Lake or things like that. Like what has prompt us to in this direction, right? So to get to that, we first need to understand from where we had begun. So in the like, let's play a scenario. So let's say you joined a company and you are asked to create reports, and you have a database, simple database. You just run queries, you run Python scripts, create dashboards, create reports, and share it to your stakeholders. Until this like life is hunky dory, everything is going fine. But now your marketing team has decided to add more third-party APIs. Someone has come up and said that okay, we want to also integrate some other data sources, some other data tables. Now the quantity of tables, data sources, third-party APIs keeps on increasing. You burn your midnight oil, create reports, still create all the reports, try to match the schema and things like that, and finally are able to publish the reports to your stakeholders by like slogging hours. But as many data sources keeps on increasing, right, this becomes at a point this becomes impractical. So that point we started using data warehouse started like came into the existence, where from different sources or multiple sources we just ETL the data into a specific read-only schema and put it into a data warehouse, right? And those like all the schema differences, all the schema evaluation, everything is handled in the transform there, and you just put the proper pristine schema into a data warehouse, and you run your queries, your SQL queries, or your Python scripts and things like that, and now you are able to solve that, right? So this is how the data warehouse, like in terms of data warehouse, came into existence. Where then people realize that with this we have not well thought about like unstructured data, and data warehouse was also very costly, and like there was a lot of upfront cost. You have to design the schema at the upfront before loading the data and things like that. So that basically gave birth to data lake as something that existed, right? So with data lake we were able to capture unstructured data. We were able to have the cost advantage of like S3 Google Cloud Storage or things like that, which is very cheap than your data warehouse storage. So all those things were available, but then you lost the acid atomicity, all those like things on data lake that was not present there. So what people started doing with data lake was they had this data lake to like take care of the unstructured data and not paying the upfront cost at the beginning, putting all the data at the starting and then thinking about the data later, and also create an ETL pipeline that will push the data from your data lake to your data warehouse. So there is like if you see in the second photo, right, There's a small subset of data that is moving to your data warehouse, whereas a batch of it that is still lying at your data lake layer, right? So now with this, they were enjoying the benefit of both, like enjoying the benefit of data lake as well as data warehouse. But then there was a problem, right? You can see, right, there's a pipeline that is pushing the data from a data lake to your data warehouse in certain way, right? So the problem with that is sometimes the pipe broke, right? And the data in the data warehouse is not as live as the data is in data lake, right? So there's that data silos getting created. Like the complexity increases. The data is sitting at two places. The duplicate data is sitting at two places. You have to maintain a data pipeline and things for that part, right? So if you think in theory, what you actually needed is a data lake. Over the data lake, you wanted a metadata properties to be handled. So that was basically provided by your data lake house, as you can say, right? So if you can see in this image, we have this data lake still available. Over that, we just put the metadata layer, and this metadata layer can be of anything. Like it can be Delta Lake, it can be Apache Iceberg, it can be Apache Hoodie, and things like that. So that basically gave us the existence of data, like what we call as data lakehouse. So if when someone asks for like ask you about why we are like we already have data warehouse, we already have data lake or things like that, why do we even need things like the lakehouse? So this background understanding might help you to answer that question in a better way. We'll also talk about other advantages that lakehouse brings with it, but like this is the high level picture that the lakehouse basically brings as compared to your data warehouse and data lake, right? So if you have already heard about Bill Inman, he is the one who is like considered to be the father of data warehousing, and his quote was, "If you want to take advantage of your data lake, the only way to take advantage of your data lake is to convert into data lake house, so that you can get the like worth of your money and things like that." So let's start with discussing about lake house. Like we have discussed why do we need lake house right now. Let's start understanding what lake house is actually, right? So if you talk about lake house, first let's say what lake house is. So if to define lake house in a simple terms, it's called as open table format, right? Now let's break this down. What is open table format? Why do we call this as open table? So we do not call this as an open table just because it uses data layer which can be Parquet, ORC, or Avro, and those are open source. So we call that also as a open open table format. Though it is built on an open source data layer, which is your Parquet, ORC, and Avro, but then there are a lot of other things which basically makes it to be called as open table format. And one of the very important thing in that is it provide opportunity to different engines like Spark, your Flink, your Trino, and things like that. There are different type of engines. Anyone can just use this data and query them. You do not need to move the data into their respective format. So let's say if you have a data and you want to be used by, let's say, ClickHouse is one of the engine. You want to be also used by Spark for some analytical reports or things like that you are preparing. ClickHouse for real-time OLAP systems or things like that. Earlier times before this concept existed, you have to move those data to those data silos, and then those engines will basically work on their specific format. But with Lakehouse, this metadata layer and this data layer that is available, this is very easily available for you to query using different engines. So that, like, other than you build on open file format, the ability to be getting queried by different engines is what basically makes it open table format is what we call that, right? So if you understand in this, can you see? Yeah, okay, I think you'll be able to see my cursor, right? Yeah, so in this, if you see the data layer, right, this is a data layer. In this data layer, we'll discuss each layer in more details just to get more understanding. But in a high level, if you want to understand, first we should think about snapshot. What is snapshot? A snapshot is a point in time. So let's say like in this particular second or microsecond that we're discussing this, that is one snapshot. As soon as this particular time frame passes, it creates another snapshot. So like there are different snapshots. Then snapshot basically points to a specific manifest list. Those manifest lists will point to different manifest files, and those manifest files will point to then to different data layer. So this blue boxes that you can see, right, that is basically called as metadata layer, and the green box that you can see, that is called as data layer, right? We'll talk about like why do we maintain this tree hierarchy and why do we maintain data in this format. But this is the high level architecture of Lakehouse will look like. So we have already discussed and touched upon this part, like the green. So we'll start from the bottom. We'll tackle each point like each of this layer at a time. So we'll start with the data layer. So on this data layer, the data layer can be anything. It can be like, so these are different open file formats. So they are like two confusing terms, sound similar, which is one is open file format and open table format. So open table format is your Lakehouse, Apache, like it's your Apache Iceberg, Delta Lake, and things like that. Whereas open file format is your Parquet, ORC, and Avro, right? So this is the data layer part. So data layer is still the open file format, and then it builds over the data layer using its tree of metadata that we just discussed to create it as a Apache, the Lakehouse, the Iceberg, and things like that, right? So in this, the data files will store two things. One is the data, actual data that we are currently having, and the other, uh, I got this prompt. Should I just remove this? Okay. I'll just quickly check the chats if anything. Okay. Sure. Yeah. So we just discussed on the data part, the data layer part. Uh, so now the data will consist of two things. One is like actual data that it has. The other part is the delete files. We'll talk about delete files more like when we talk about copy on write and merge on read. It's only applicable to merge on read, but let's not go into that complexity. Just keep in mind that data layer consists of two things that it stores. One is the actual data, and then other part of that is delete files. Delete files is basically what it stores. So these are two things. Either you store that in a Parquet format, ORC for an Avro format, right? So we are clear at the data layer part. We'll talk about the other tree hierarchy. We'll just try to zoom in a little bit. 1 second. So that you can see. I'm not sure, like it's not zooming enough, but if you can see, you can zoom it from your side, or you can check that these are the tree hierarchy that we are talking about. So in this, there are three components. One is metadata, the manifest list, and the manifest file, which you have already discussed here, right? So we'll just quickly walk through them. What is specifically that this is the part where the magic is, right? So we already had open file format. This is where the Apache Iceberg creates magic, and this is why it is much better than plainly using open file format, and where open table format basically shines away over there, right? So we need to understand what each file basically contains. So in metadata, if you want to understand, just think on this. If you can see on your screen, or if you download the slides by yourself, you'll see snapshot information is there. We have already discussed what are snapshots. So you'll get the snapshot information. That's a list of manifest list, right? So any changes that you do to your iceberg table, maybe you insert, delete, merge, or anything like that, it will create its own snapshot. Every snapshot will have its own manifest list, as we discussed in the previous slides, and then manifest list will point to its manifest files, right? So in this metadata layer, we'll get to know what are the available snapshot that we have for this table, like what are the different changes that this table has undergone through, right? And those snapshots connects to which manifest list, right? So this snapshot, which is the current snapshot, this is the current snapshot, this is the ID which is currently showing up, and this points to a particular manifest list. Using this manifest list, you can go to the specific manifest list, right? In this manifest list, you will get the partition lower bound and upper bound. We'll talk about like this partition and things like that. If you are not aware about partitions and things, we'll talk more about it. But for now, you can just think of this basically helps to reduce the data scanning and metadata scanning, right? Things like that. Just keep that in the mind, right? So once you get the current snapshot, the current time window of this particular table, then you will point to that manifest list. You go to that manifest list, you'll see the lower bound and upper bound of that partition, right? And using that information of the lower bound and upper bound of the partition, you will select a manifest file, right? Because this will give you the manifest. In the manifest list, you will also get the manifest file information. This will give you the manifest file, and in that manifest file, you will have for each columns lower bound and upper bound values and things like that, right? So when once we will discuss on like the optimization part of the iceberg, these things will be very helpful to understand. Any questions, anything till this point? I'll just check quickly that. Okay, I think we'll handle the question at the end, but anything, if you are like not able to see on screen or fonts are not visible enough, just feel free to ping in the chat. Cool. So we have discussed till now the architecture of Apache Iceberg, the metadata layer, then the data layer part. I think we are clear till there. There could be few doubts on the partition and things like that if you have not worked with those things, but we'll definitely tackle this in the later part of the slides. Uh, Cool. So this particular slide is the so when I was creating this slide, this is the slide where I was stuck like for like 5 minutes. This is very boring, but if you just stay with me for this slide, it will be like this. This will clear many concepts that you might face when you try to understand COW, MOR, and things like that. Though this slide is little boring, but hang around for some time, try to understand that, and like then life gets simple using Apache Iceberg, right? So we have all discussed few components of Iceberg. There's some chats. Okay, zooming in Chrome helps. Okay, I'm not able to zoom it from my side, but if this is zooming up things, then it's good. Okay, so we'll just start with different things, right? So let's say you are adding two data files. Data files we have already discussed what data files consist of. So each edition of data files will basically create a manifest list and manifest files. So in manifest file, you will see that you have added two data files, data 1 and data 2, which are added, and then they are subsequently pointing to their own data files, which is like shown in the green boxes, right? Now you delete the data one. So always remember a fact, whenever you delete a file, it will create a different manifest file, right? So what happens if the existing data one that was already there, you just deleted it. There's some operation that you might have done because of which data one file got deleted, right? So now if you see in this will create a different manifest list as well as a manifest file. Now this manifest list, which was earlier manifest list 1, is changed to manifest list 2, and it is pointing to the manifest 2 file. It is nowhere pointing either to manifest 1 or manifest list 1. It's a new manifest list and new manifest file. But if you see right, this manifest file points to both of these data files, data 1 and data 2, right? So because we deleted the data, hence the new manifest list and manifest file got created. Now let's say we are again creating data 3, adding a data file again, right? We earlier learned that it will create a new manifest list if you delete the file. But if you're adding, there is no point in creating again. So what you can do is this manifest list, because you're adding, you're not deleting here. So this manifest list will point to both manifest 2 as well as manifest 3, right? In manifest 1, in manifest 2, you'll see data 1 is deleted because I've deleted the data 1, data 2 is still existing. So it will point to that. It won't redundant that information. It will just add an additional new information, which is that data 3 is added. And this manifest takes care about talking about both data 1 and data 2, whereas this manifest talks about only about data 3, right? And same thing happened when you delete the data 2 and add data 4 again, right? So this is what will happen when you this will become more helpful when we'll talk about COW and MOR. But this is how the manifest files and manifest and data files changes as per your operation that you apply on, whether you add a data file, delete a data file, and things like that. What happens under the metadata layer of the Apache Iceberg is what we are currently talking about. And this will be very helpful when we will talk about the next topic, which is COW and MOR. So they are basically COW is copy on write and MOR is basically merge on read, right? So in COW, the same thing we are doing. So earlier, let's say we had a table where everyone was having their favorite fruit, right? So Jack's favorite fruit was apple, Sarah was orange, and John's was pineapple. And you wanted to update Jack fruit to banana, right? In COW, you will create a new manifest file. You delete the older one, create a new manifest file, right? And rewrite everything. So that if you, okay, we'll talk about that later. But it will create a new data file. It will create a new manifest file. And it will point to the older data deleted files, which was the case when we did delete data 1. We created a new manifest list, new manifest file, but the new manifest file was pointing to data 1 still, right? The deleted part. The same thing is happening here. This is still pointing to data 1, but it has updated and created a new data 2 as well, right? So that's how the COW happens. And in the MOR part, it don't delete and recreate everything. Instead of that, it will just create a delete files. Remember, we talked about it in the data files about the delete file concept. So this is where the delete files basically comes into the picture. So in MOR, merge on read, it will create a delete file, right? And it will point to a position, zeroth position is where we want to delete. So instead of deleting and recreating the everything, it will say that, okay, I want to update Jack with banana, and where it lies at position 1, right? So that basically is your delete file. And then once you run optimize or things like that in the background, this delete file also gets, like, after certain time, not in the real time when you are updating the data, in background it gets and get updated as like a one single file like this, but it doesn't happen in the real time, right? So if you try to think what are the advantages and different disadvantages with both of the approaches, because everything has its own pros and cons, right? So with COW, the major advantage is on the read time, you don't have to worry much, right? Because everything is already updated. But in the merge on read, you at the read time you have to worry, because you have to create an updated file depending upon its position vector and things like that, right? But in COW, at write time, there could be a lot of write amplification, right? It could create a lot of write because you are deleting and recreating everything. But here in merge on read, it's not, because you are just adding a position pointer, you're not updating the file as such, right? And then there are two type of merge on read. I'm not going to in much detail about it, like position delete is what we talked about. Then there is equality delete, where instead of pointing to a position, you just say, I'm not even going to find the position, I'll just say update Jack. And now it's on the job, like at the point of reading, it's job of your engine that it has to merge and find the Jack that is at position 0 and update the record accordingly. I'll just quickly check chat if anything. Yeah, I'll talk about partitioning, the data and partition evolution. Definitely, it is in the future slide. Cool. So I think we are clear till here. We'll talk about catalog. So I have been working with open source technologies a lot, right? Like I've been working with Apache Airflow, Apache Iceberg, and things like that. So I was also noticing where different vendors are creating the logins. So because this open table format has changed the game, right? So earlier, if you have been in this field since long, you have been aware what the Databricks used to have, like Delta Lake, which they have recently open sourced, right? So this open table format was not open source until Apache Iceberg came into the picture, and Delta Lake then gradually open sourced, but it's still not yet open source. There is still like a lot of nuances in that. But Apache Iceberg is something which has made this vendor lock-in to go away. Now vendors are trying to find different points where they can still do the vendor locking, and the catalog is the next part where they're still planning to do the vendor locking, right? So AWS has its own AWS Blue catalog. It do not want you to move away from it, so that you will be using AWS Blue catalog and things like that, right? So that's a catalog is very important. This is the next place where vendors are trying to create the basically lock-in part. So let's try to understand what's the use case of this as well, right? So catalog has three major functions. It will have the list of all the Iceberg tables that you have created. It will keep the most recent metadata part that we are talking about, and also it will help in achieving the consistency that we promise with Lakehouse tables, right? So they're like Iceberg would be used. So let's say if you have a very open source catalog and things like that, then it will allow all the engines to query from it. That is like actually open in an open sense, right? But let's say you have a Snowflake catalog, you will allow all the engines to read from it. That's fine, but you will not allow the engines to write to it, and that's where you create that vendor lock-in part on that using the specific catalog. So a different specific catalog, Glue, Hive, JDBC, REST is the go-to right now. Even Glue started supporting REST catalogs, so that because it removes your dependency on specific language and all those things. Yeah, those are the specific catalogs that we can use, and using that we can like start breaking down the silos with Iceberg catalog, right? So these are two things which I wanted you. These are very critical for you to understand how we've already discussed what happens when you write and read, but to actually understand this magic more in detail, and also walk you through the different steps that happen when when you write or either when you read, right? So first of all, let's you want to write a write file, right? You go to the catalog that we have just discussed. From the catalog, you'll get a metadata file. From the metadata file, you'll get schema and partition schema. Using that schema and partition values, you'll write the data file. Then you create a manifest list over then you create a manifest file. Over the manifest file, you will create the manifest list. Over the manifest list, you'll create the snapshot. And now here is where you should pay more attention, right? while trying to register your metadata, which is your current snapshot or things like that, to a catalog, this is where your consistency or atomicity is basically is taking place, right? When you're trying to register to that particular catalog, I'll walk you through the so just keep into this mind that this is the part we need to talk about when we are talking about consistency. The read is very magical, which happens, right? So you go to the catalog, get your metadata file, again schema, partition schema. From there, as we discussed, your metadata file has the snapshot information. From the snapshot information, you will get which manifest list I need to go to. Then you go to that manifest list, check their higher bound and lower bound of the partition. Using that, you go to the manifest file. In the manifest file, you'll get different column, high, up level and low level ranges. Using that, you go to the specific data file and then finally get the result. So like if you see, like a lot of pruning is happening behind the picture for you to get the result. This pruning was not available when you were having open file format, but then it's still debatable. Like there's a lot of optimization basically read operation provides. Yeah, so if you remember, this is the part of consistency which I was talking about, how Iceberg supports it, right? So let's say there are two writers trying to write on the same file, and different operations are available. You first scan it, write the data, refresh the metadata, check the conflict, write the metadata, and commit it. So let's say there are two writers trying to write on the same file, start at the same time. So if you'll see, both of the writer have their current snapshot on which they started writing on, and the new snapshot that they will create after writing this, right? So the writer one has a current snapshot one, and then they will create a snapshot two. The writer two also started with the same understanding that I will start with snapshot one and I will create the snapshot two. But if you see, writer one was very quick and it just committed everything into the catalog and changed the state of catalog to currently snapshot is 2 and new snapshot is 3, because it has put his commit state of new to its current and changing its current to snapshot 2 and the new snapshot 3. Now, because the writer was little slow, when it tries to commit it, because it had only the knowledge of that its current is snapshot 1 and new snapshot 2, it fails because that's not the actual state of catalog right now. It has got updated, right? Then it will again do the refresh metadata, conflict check, write metadata, and then finally commit with the snapshot 2 and snapshot 3 things. So that's why like catalog is super important. Super important when we are talking about this, right? Just quick time check, 29 minutes. I'll just have like try to close this in next 5 minutes. Okay. Cool. This will we can also talk about more in detail in our Q&As. But like everything comes with its own baggage, right? We have understood that okay, read is too optimal. We like over the open file formats, we are able to get a lot of performance boost. And we can also do historical travel and things like that, right? But it also comes with its own baggage, because any update or insert or delete in your table creates a snapshot. So you should be very mindful about how much snapshot do you want to keep, right? So that's like just a meme. If someone has watched Mirzapur, like whosoever has come till now has to go, right? But you have to decide how much do you want to expire, right? Till what snapshot you want to expire. AWS maintains all those things for you. You can just set up that, okay, I want this compaction to snapshot to be removed after this many days, orphan file to be removed after this many days, or you can also handle this manually, right? Though handling manually comes with its own pros and cons, but this is how it is. This slide will definitely talk about when we are talking about Q&A. Yeah, someone has asked partitioning evaluation or something like that, right? Yeah. Okay. So one of the key advantage of using Iceberg over the normal height table is, so I'll just quickly tell you what a use case. We had our analyst team who were, and every time their query is not running, not optimized, I'll just go and tell them that, okay, sir, please put year, month, and day filter in your where query. And they most of the time they remember for the next 7 days, and after 8 days they'll again forget about it, and then they'll not put year, month, day filter in their where predicate, and they'll just run the query on the timestamp or things like that. Iceberg solves that. Instead of putting year, month, day filter in your where query, what you end up doing is you just pass the transformation. Say that I want this table to be partitioned on the day level. That's it. You don't, then in your where query, you don't have to put where predicate, year equals to 24, month equals to 10, and day equals to all those things. All those transformation is handled by Iceberg internally. That was not available with your like Hive table and things like that. Then there's also partition evolution. So let's say you're a small startup and your monthly data was not that much. But suddenly, like after you have got some big customers, and those big customers have made your monthly data to be non-queryable. And now you, instead of month partition, you want that to be day partition, right? So you just, with earlier Hive tables, you have to rewrite the whole table into like your day partition, month partition, change everything. But with this, you don't have to do that. Just say alter this table, start doing this at a day level partition from now. For the older data, I'll take a call later. But from now, you just start doing it on a day level instead of month level. And your table, from that point where you alter that table, from that point it will just start behaving as a day partition table instead of month partition table. So that is like there are like some differences the way it handles versus the Delta Lake it handles. People have preferences around that, but yeah, this is the last thing that I just wanted to talk about. Uh, is there anything else? Yeah, the last thing. Okay, so with this talk, what my intention was, right? With this talk, what I wanted actually is to get you. So, if you're a beginner, you wanted to understand the difference between Hive table and Iceberg table. I want you to get excited about this because this is the next big thing. Uh, there are a lot of discussion happening, like people who will build around this Apache Iceberg, and like the Lake House would be the people who will be very successful in this data engineering domain, right? So think about different use cases that you can build around it. And just to motivate you in that direction, I just talk about a use case that a particular product has built using Iceberg, right? And that is currently challenging the already built and battle tested Kafka setup by providing a much cheaper and comparable latency. When I say much cheaper, I'm talking about 8x much cheaper, right? So it's like people are building around these use cases, and there's no doubt that you should also start building around these things. So what they do is, so there's a product called as Buff Stream. So what they thought about is, would think about, if you are aware about how Kafka works, I'll just quickly walk you through. So they have this disk storage, and they have this disk storage where they'll push, like, so you already aware of like producer, consumer, and broker, right? I'm not talking about that detail, but at the broker level, you have this disk files and things like that, where any data that you're writing to broker is basically getting written to your disk level, right? So your computation and storage is tightly coupled. Then Uber came up with their own KIP 405, where they wanted to move towards tiered storage, where they do not want to that coupling to be that tight, and also wanted to store tiered storage, which is S3 and things like that. So what started happening is your live data will be still in your disk storage, but your like older data will go to your S3 data. These guys changed the game. These guys said, okay, we'll not use this storage at all. We'll put anything that you are getting into your like cloud storage, S3, GCS, and things like that. That is one part. And thinking in that direction solves two purposes. One is they do not have to worry about, so if you so Confluent is the one which is selling the solution over Kafka, right? And their biggest pitch was, don't deploy Kafka by yourself, let us deploy for you. The reason behind that, we handle AZ replication too well that you will not be able to get that cost optimization. These guys said, okay, I'll not even do I'll not even do AZ replication, like cross AZ replication. I'll just put the data into that bucket and cloud storage. And I'm too sure about the durability of the cloud storage that I will not even need to replicate it across AZs, right? So that's the major biggest cost reducing part. So there are two things by which the cost reduce. They use cloud storage over the disk storage. Don't do disk they don't do cross AZ replication. That's the second point. And the third point is they can serve consumer reads as well as analytical needs just by Iceberg. That like these three basically reduce 8x, but then there is some cost like because you are saving on cost that much, you have to bear the latency part, but the latency is still not too bad, right? If you see, the median is around 260 millisecond, the end-to-end latency median, and and P99 was around 500 some odds. 500 missing is still too good at this cost, right? So that is it. Getting started, there are like few articles that you should definitely go through to get more hands-on and get more understanding about this Apache Iceberg. There's a lot, like a different APIs that Iceberg provisions. You should go and check it out and see how different engines basically execute those, implement those things, just to get more understanding and start building around this. This is it. You can connect me on LinkedIn. This is a QR code. I also mentor people. So yeah, you can reach out to me anytime on this. That's it. Thank you. Harsha, I'm good from my
Yes.
side.
Thank you so much. That was really helpful and elaborate to all of us as well. We have received a few questions from the audience. First, I would like to read those out, and then we have some questions that we have received from our community as well. So after that, I will be putting on to those questions. Is that okay with you?
Makes sense. Makes sense.
Just give me a second. Yeah, first question is from Siddharth. He asks, can you compare the schema validation process used in BuffStream versus the Kafka approach?
That's a very good question. I didn't got time to cover that. So yeah, that's a very good question. Actually, if you think about how like data quality is handled at Kafka level, it's handled at client level. So you have your producers producing data, you have your consumers consuming data. So what happens is your producer uses schema registry, get that schema ID, serialize your message, send it to the broker. Your consumer get that schema ID, deserializer and consume the message. Your broker is stateless; it do not know anything what is happening. So if your producer go rogue, it start producing message without following any schema registry, right? There's no way anyone can control that. So that was the reason with which Kafka was having this spill issue, like data poison issues and things like poison message issues and things like that, right? But with these guys, bus streams, so they have handled it very elegantly. So what they are doing is they make their schema as a first class citizen for their broker. They register with that broker, and their broker is very able to classify or declassify between those messages which follow a specific schema or don't follow a specific schema. Where in the Kafka, your broker was stateless, it just sees your message as a bytes and things like that. It cannot evaluate. Where your buff stream broker is very well, because these guys are creating things on protobuf mostly. So that is it was their domain. Kafka cannot come into that, but then they go into Kafka zone and try to disrupt them. So yeah, they handle that very elegantly. Thank you for raising that question. Thank you. Yeah.
Thank you, Siddharth, for this question. And the next one is from Shubham. He asks, what is Z indexing and how it helps to query the data?
Yes, that is also another good question which I have not covered in the slide. Right. So let's talk about what makes query faster. The two things. One thing is reducing the metadata that you're scanning so that your query planning and things like that get reduced. And the second part is you're reducing the data that you're scanning. Your Z indexing comes into the second part of the picture, where you want to reduce the data that you're scanning, right? So you partition first, like partition we have discussed a lot about, right? So first you partition the data, and that will reduce most of your data, like prune most of your things like that. And your partition is always on the low granularity column. So low granularity is like dates, because like in dates you have just have 31 values, months you have like 12 values. Low granularity columns you should use as a partition value. But for high granularity columns, you cannot use dates because then it will get small file size problem, right? So with that, people started doing sorting. But then sorting works with one column if you are querying on one column. What if you have like multiple columns to query? There basically Z ordering comes into the picture, where it tries to fit the data in a Z curve or some sort of, right, which will have the closely related data on different columns which are high granular and things like that getting organized in a Z curve, so that multiple columns, if you are querying on multiple columns with high granularity, you can query them by putting by Z ordering the table and things. So also little difference how liquid delta table handles this. So they do not. They currently are asking people to go off from Z ordering and start using liquid clustering. like I can share some articles on that. But liquid clustering is much better than Z ordering because it's on Hilbert curve as compared to Z order curve. That's one difference. The other difference is it is auto optimized. So if you run a lot of queries, right, you don't have to tell, okay, now make my table Z ordered on this column, which you have to do with your Z order. With your liquid cluster, you don't have to do. Just say, analyze my query that I have done on this particular table and decide for yourself. And it will keep on changing all those things, right? So yeah, on a high level, this is what.
Thank you, Shubham. Hope that answers your question. Moving ahead. Uh, so yes, we have another question from Abhinav. So he asks, REST catalog or Hive Metastore, which one do you prefer in a multi-engine setup, and the reason behind it?
Yeah, another good question. Now I have slightly tried to cover that in my slide. Yes. So I would prefer anytime REST catalog. The reason behind that is I do not want my engines to be specifically defined by Hadoop system, Java system, or a specific language or platform things, right? I want that to be agnostic. So REST catalog implements different APIs, all those like different APIs which Iceberg provides, and any client which is able to do REST queries, RESTful queries, right, would be able to use your REST catalog as compared to like different other alternatives that we have, which is Hive, Glue, and things like that, right? For that, like either it is a language dependent or it is a platform dependent, whereas a RESTful endpoints are too simple. Like any client which can just implement RESTful queries can basically help that part.
Thank you, Abhinav, for this question. Another question is, uh, so yes, Merlin has asked, how does Iceberg's time travel capability compare to traditional backup strategies?
Yeah. So traditional backup strategy is what I think you're talking about, DR, disaster recovery, and things like that. It is something in that way, but so we had with Hive table, we used to create history table. So what we used to do is we used to create append only tables when we do not modify that, whereas with your Iceberg table, you just modify and put that state in time. With I with this snapshot, you have this power in your hand, and with power, it comes like with great power comes with great responsibility. You can control till what snapshot do you need data. Let's say you don't need, let's say, 5 months of data or 3 months of historical data or things like that. You can control with that. Handling those things in a backup study is sometimes a little trickier, but both could be your like some sort of uh, comparable part. The one of the major advantage with this Iceberg's time travel thing is because it's a snapshot. It is not like you're not querying the whole table, you are querying a specific snapshot. So you go to the metadata files, you get that specific snapshot that you're worried about. Let's say 10 days, like from now, previous 10 days of data. You just go and query only those 10 days of data. You don't have to query the whole DR table, disaster recovery table, or backup table that you would have created by appending. So that basically gives us data that you're scanning as well as the metadata that you're scanning in some sense. I hope that is helpful.
Okay, sure. We have two other questions, but I think you have already answered those, so I'm not repeating it. Okay, so we'll just begin with the questions that we have received from the communities as well. So, one is, once we decide a partition key, how to change it later as query requirements change with times.
Yeah. So again, that's a good question. We just try to touch based upon it, right? So let's again like the same example that we just discussed, where we had like earlier you were a startup, you had a smaller data set, you were able to query monthly data, but from now this time being you are not, right? The reason behind that is the data has grown tremendously and you cannot query your monthly data. So you want your partition to be evolved to your daily level instead of monthly level. With your Hive table, it was not possible. With your this Lake House table or Apache Iceberg tables, it is possible. And the way you can do it, you can alter the table right now from this point and ask it to keep the data at the day level instead of month level. And your older data won't change anything. It will be still at the month level, but your new data from the time you have started growing your data volume, at this point it will start clustering the data into the day level, and you can just evolve that. So alter table that way. But maybe in future, like after 10, 15 months, you decide that okay, I want my older data to be also following this day level optimization. You go and rewrite that. With Hive, you have to rewrite. There is no option. But with Iceberg, you have option. You cannot. You don't want your resources to be used right now. Just don't write it, right? Versus the Hive table, which we discussed.
Sure. Another question that I see a lot of people asking these days, like, what are some best practices for implementing and optimizing iceberg tables?
Yeah. Uh, okay. Let's talk about this from first principle. Okay. What makes what makes a query faster? Your query is faster because of two things. Two things you can do to your query to make it faster. One thing that you can do is reduce the metadata that you are fetching. The other thing is you can reduce the data that you are fetching. How can you reduce? Let's talk about the metadata first. How can you reduce the metadata that you are fetching? So we talked in Iceberg. We talked about already the tree architecture that it has. Yeah. In this, you know the partition lower bound and upper bound in the manifest is stored. So you, depending on your where predicate, it will just go and check that particular manifest list, and it will prune all the metadata other than that. So query planning is becomes much faster. The second thing, which is still in the discussion happening in Apache Iceberg community, is different engines are caching of the data, metadata basically. There's still some discussion that when you make your cache invalidated and things like that, but you cache the metadata. So with all this optimization, you are reducing the metadata that you have to work with, right? So query planning becomes faster. That is one part. How to make your query planning or your metadata fetching faster. That's first part. The second part on the data scanning part. How can you reduce the amount of data with that? So couple of points on that as well. One is partition pruning. We have already discussed a lot about partition pruning. You can decide on partition that you want to keep the data in. You should always have like smaller files. Do not have a smaller files. Like 1 GB of files still okay. It doesn't make sense to have like 10 MB, 15 MB of files in that rate. Merge small files into bigger files, right? And always remember this fact that don't run behind a faster engine, but run behind scanning less data. What you can do to scan less data? You can do partition pruning, you can do file compaction to reduce the round trip. Then you can also do like Z ordering and things like that we just discussed. Right? Z ordering, liquid clustering, and things like that. Like liquid clustering not definitely available with Apache, but it's a Delta Lake property. But Z ordering is still available, right? So those, like you should think, what should I try to optimize? Should I try to optimize metadata? Should I try to optimize data? Then think about different ways to do that. In data, in data, you should also like snapshot retention, which we just discussed. Like you should not be holding, let's say, 10 months of data in your table, right? Which will again become the case of disaster recovery or backup strategy, right? So yeah, that's like a high level.
Thank you. Here's an interesting question. What are the challenges you still see with iceberg, like, as a data engineer yourself and based on, like, other customer feedback?
Yeah. So uh, I've been working with Iceberg and Delta Lake side by side, right? Iceberg dependency on catalog, and that is becoming the vendor lock-in point. That is biggest problem that I see with Iceberg. With Delta Lake, it is much beautifully handled. They have this Delta log underscore Delta log table where they have this all this transactional log getting recorded as an append only log, but they do not explicitly need a catalog, which Iceberg needs right now. That's the biggest problem that I see because that is the point of vendor lock-in. But I see some people are starting contributing open source to make Apache Iceberg catalog independent. I'm not sure on the status of that, but that is currently the biggest problem that I see with Apache.
Hmm. Interesting. Anyone who wants to add on that, please, either you can raise your hand or even just write in the chat box itself. I'm really curious. Okay. Here is one personal question that I wanted to ask you, Sachin. So basically, I have seen you talking to many Iceberg and ClickHouse conferences, and I was just wondering, if you have tried integrating Iceberg with ClickHouse, and if yes, what's your take on using them together for OLAP workloads?
I have not yet, but I'm really curious about it.
Yeah.
There is a I'm consulting a team. They have this medical history of records and things like that, lot of data and things, and they want that data to be quickly retrieved. Uh, those things, right? And they are using ClickHouse.
Okay.
There I'm currently proposing to use Apache Iceberg and ClickHouse because ClickHouse engine is currently supporting Apache Iceberg queries and things like that.
Yeah.
So that would be a very helpful understanding for me to try it out, but I have not done. And that's like a very fascinating point where I'm sitting right now. And because you reminded me on Friday, so could be like the weekend that I would be spending to try this out.
Awesome. We would love to hear your results as well. Okay, the last question. Yeah, this is the last question, and I'm really curious to know this answer as well. So, what emerging trends around Apache Iceberg are you most excited about, and how do you think, they might change data engineering practices in the coming years?
That's a wonderful question, and this should be the last question, like perfect last question that could exist, right?
Yeah.
Yeah, so I am very interested in this field. That is first part. The the most exciting thing about, so with this Kafka thing coming up, right? This buff stream, everyone now is thinking about writing into Iceberg first, right? And those like this buff stream guys, right? They're a small team just trying out few things, right? They have they with this writing the Kafka data directly to Iceberg, right? Instead of writing into disk storage. That's like very fascinating, and it should be the first thought that should come to people, but it has not because it was always the Kafka way that people used to think about, right? And that they have competed with the Confluent, the biggest guys in the market, right? And competed with them. Confluent came up with this. They have just recently acquired Wasp team, and they have come up with a table flow where they talk about table and Kafka topic dualities. They say every Kafka topic is a table, every table is a Kafka topic in that something in that sense. But they still do copy the data and create iceberg. They are not native iceberg, where these buff stream guys are native iceberg. They don't copy, they directly write to iceberg table, right? And that is like you see a small guy coming into this picture and challenging the way people used to do things since long is quite interesting, and that was only made possible because of the blessing of Apache Iceberg. Yeah.
I mean, tell me about it. Wherever I see, my LinkedIn feed is filled with Apache Iceberg, their summit conferences. Everyone around the globe is talking about Apache Iceberg. So, of course, we equally are so interested and excited about what's coming next.
Yeah, and we've been
That's
connected on LinkedIn, right? I think you will see more mutual Apache Iceberg slides and things because I have also been sharing and reading more on those parts. So that could be also one of the
Oh,
reasons.
great. I am comparatively new in this space, reading more about it, understanding more. So it's one thing that keeps me hooked the most. So yeah,
Sure,
definitely.
sure.
Yes, I mean that's it with the question. Sachin, by the way, you also do a podcast of your own, right? AI pe Charcha. I just saw on your LinkedIn as well. Do you want to speak about it to the audience?
I used to do that since like few years I've stopped, but that has not stopped my urge of talking to different people on different technology and speaking on that part, like this different technology, the Apache Iceberg and ClickHouse and things like that. So instead of creating a YouTube videos and things like that, started mentoring people more personally because that gives you a personal touch, right? So yeah, so instead of, because the YouTube is like you're talking to a camera, that is not very exciting than talking to a real person. So I've started investing more of my time in talking to people, And like in this slide, I have attached QR code. So anyone want to connect with me on LinkedIn or get some mentorship or things like that, anytime can reach out to me, and we can take it from there.
Absolutely. It was wonderful collaborating with you. Like one of the most exciting times when I've done the webinar, the content, I got so much to learn from, and I sincerely hope everyone enjoyed a bit of it as well. Lastly, I will just say, just take 1 minute to say one thing. So, lastly, when I was talking to people about the webinar, I was getting asked a lot about OLake and what it is, we are really doing over here. So, I'll just take 1 minute to just explain it to the people over here. And in simple terms, we are trying to build the fastest replication of databases into data lake houses, currently using Apache Iceberg. And the sources that we have built right now are MongoDB, Postgres, and MySQL is coming on board very soon. So, using the time constant, we are ending up. So I won't explain more about it, but I would like to invite people to our community over here. Whoever wants to join in, whoever wants to ask a question here, it's completely open sourced. So completely, you're welcome. Ask a question, and I am absolutely excited to see you all on board there as well.
More power to open source.
Yes, likewise, Sachin. Thank you so much, Sachin. It was wonderful. And
Thank
anything that
you.
you have to say?
I'm good for now, but yeah, I look forward for this OLake thing in the future and see open source growing bigger and bigger. Thank you so much for
Absolutely.
organizing this and having me.
Thank you so much for coming along, and thank you so much for your best wishes. Thank you.
Thank you. Bye.
Thank you so
Bye,
much, all
folks.
of you, to join this webinar as well.